Hey, and welcome to today's Devtoberfest session, the superpowers of CAP CDS, calculated elements and annotation expressions. And before we dive right into the session, I wanted to quickly introduce you to today's speaker, who is Stefan Weinstock from SAP. He is part of the CAP team, of the core team, and his role is currently a product owner of the compiler team. So that's going to be interesting what he's going to tell us today. And with that, I stop talking and hand it over right there to Stefan. Enjoy the session.
Yeah, thanks, Kevin, for the introduction. Also, welcome from my side. Before I dive into the topic, let me do two disclaimers. First of all, as mentioned in the abstract, this is a kind of advanced session. So we assume you're already at least a little bit familiar with CAP CDS, with writing basics, CAP CDS models, and also with using tools like the CAP compiler. Second thing is this is about CAP CDS and not ABAP CDS. So although they have pretty familiar and similar syntax and share common ideas and common syntax, common techniques, the advanced features I'm going to talk about today are, at least to the very most part, only available in CAP CDS. So I don't only want to talk about the two features mentioned in the title, but also go a little bit into the details of managed association and extend, but due to the amount of time which is restricted, I will be pretty brief on them. So without further ado, let's go to the first topic, which is managed associations. Now switch over to my editor and go there. All right, so you all should be familiar with an association like this, where we have a on condition. And so we have a books on entity, we have an order entity, and an association going from books to authors with an explicit on condition. So this is what we call an unmanaged association. Here you have an explicitly modeled foreign key element, which you then refer here in the on condition. You can also write an association like this. We just say author, association to authors, and that's it. The important decisive part here is there is no explicit on condition. This is what we call a managed association. And the reason why we call it managed is because we take care of the foreign key and we take care of the on condition. So in a way, this managed association implicitly is or behaves also like a structured element. And the sub-element of it are just the foreign keys that are needed to match the key of the target entity. And when an on condition is needed, we just compute it on demand automatically based on this foreign key information that we have. So we can just have a look at the season that is coming out of it. So if you start the compiler and look how this looks like, then we see we have here the author entity. There is no key stored, and there is a reference to ID. So we have information about the foreign key, but it's not explicit. Implicitly, what we do basically is more or less we automatically have the foreign key. If flattened out, it would be looking something like that. And if we would generate the on condition, it would look like that. Yeah. But you don't have to write it down. It's all implicitly done within this managed association. And that's the beauty of it. You can just write association to authors. You don't have to care about a foreign key. You don't have to care about the on condition. So it's a very convenient way of writing such an association. Now, what is very important to think about is cardinalities. So here it's from the construction pretty clear that this must be a to-one association because here I have a foreign key where I can store the key of one of the target instances. So you can now make this explicit by writing one association to one author, but you don't have to because one is the default anyway. You can just omit it. But what you should be aware is that the cardinality that you write down here, or the default cardinality, if you choose to don't explicitly provide a cardinality, is purely descriptive. So the real intrinsic cardinality of an association is determined by how it is defined, so how the on condition looks like. What you write down here does not change how the association works or doesn't change the real cardinality of the association. You really make it only explicit what is defined implicitly anyway. So you can write one, that is okay, but writing many here would not change the association itself, but would just be wrong because it is an to-one association. And this is a mistake we oftentimes see. Yeah, people now going to the author's entity and want now define an association pointing to the books that this author has written, which is a to-many association. So people write association to many books without an on condition and think, well, I have defined myself a nice to-many association. And that's unfortunately wrong, because what here happens is the same as above. We implicitly construct a foreign key. We implicitly define or compute an on condition. And what you have actually is a to-one association. So if you really want to have a to-many association, you have to provide an on condition. You could do it this way. So this is the manual way, in a way, by saying, okay, I just tie the author ID, so the foreign key. Well, I should use maybe rather this one here. So where I tie this foreign key to this ID here. But there is a more convenient way, because we already have an association pointing from books to author, which contains the on condition. So we can just refer to this other association and basically tell the compiler, well, take the on condition of the counterpart of my partner and just, in a way, reverse it. And the syntax for doing so would be just to write books.author equals $self. Yeah? So that just tells the compiler, so this is an association that points to me. Just take this on condition of that association and reverse it. And by that, you have everything you need. I should also briefly mention that for compositions, the game is completely the same. So if you write composition of items and think you now have defined a composition of many items, it's the same mistake, because again, here it works like association. You have a composition of items, so we implicitly generate a foreign key and do the on condition. So again, you have made a one association pointing to one of the items. The correct way of doing this composition would be to go to the child entity items and define an association that points to the parent, so an association to order. Here we can again use the manage association. And then in the parent, in the order, we say, okay, again, non condition, and do the same trick, items.order. So pointing to that association is my counterpart. And now I have linked these two. And without writing one explicit on condition with foreign keys and so on, we have just linked these two entities together. So I mentioned this because we have the feeling that in particular for the managed associations, so how it works with this foreign key stuff and the thing with the cardinality is not clear to everyone. This is what we see from questions, from issues. I thought it would be good to, again, put that up here. All right. Then the next topic I have on my list is extend. So let me first do some preparations. Okay, close this. Close this. All right. I should first of all do a little explanation of the term extensibility as I'm going to use it here in this session. So first of all, as this is a session about modeling with CDS, it's about, of course, model extensions and not code extensions. Second, I don't want to talk about allowing users of your application to make extensions to it in the sense of a key user extension, but rather I want to explain how you can make use of the extension concepts of CDS in your own model, for example, for doing separation of concerns or for doing mesh up with reuse models or with imported models. So with that said, let's have a look at this example here. So again, I do something with books. I want an entity books, which I have built myself. This time, I don't want to model the author entity myself, but I found a great reuse model, which I have imported, which does the definition of a author's entity. And I want to make use of this one. So what do I have to do? First of all, I need to tell the compiler, hey, if you compile this file, my model, you should also compile the file that contains the definition of the author. I do it with the using statement in the beginning. This using has three jobs. Job one is to tell the compiler which is the, well, transitively tell the compiler which is the complete set of files that should be compiled. This is done by this link to this other file. The second thing is In a CDS file, you only can reference local names. So you cannot inside a CDS file just say, okay, and now I want accessing people authors. In a CDS file, you may only access locally defined names with one exception. And this one exception is the using. Here and only here in the using, you can access an external name and give it a local alias. So you could write foo and then access the author's entity defined in the other file here by the name foo, or you just omit this explicit alias and then you get an implicit alias, which is just the last part of this path here. So we have now defined an implicit author alias that points to this external entity. And now I use it. I define an association, a managed association pointing from my books entity to the imported author entity. But again, looking at this author's entity, I realize there are some things missing. So I want to have some address information about the author. For example, I want to have a city and a country element in the author's entity. But as authors is an imported file, it may be that at some point later I re-import it in an updated version, and then if I would just modify the authors itself, it would just my modification would be gone. So I do it with an extend. I do it here in my file, and in my file, I just say extend the authors with my additional fields. So I kind of inject them into that other entity definition from here. And in the same way, I can also add an association that points from the imported author entity to my books entity. One remark on this element extensions, if I would try to extend authors with an element it already has, for example, the name field, then the compiler would give me an error. I cannot only add elements or associations, I can also add annotations. So in this case, I want to add, well, actually not add, but I could now add any kind of annotations to the author's entity itself or its elements. But in this case, I want to do the following. Authors already has a name, and name has already an annotation title, but I don't like that annotation. So what I can do now, if I do an annotate with an annotate, then this replaces the annotation in the base model. Yeah? For an entity, that would not work. I cannot extend with an element that already exists, but I can add an annotation that already exists. In that case, I overwrite it. So now my author entity would have a name with this new annotation. Next thing is what I want to do. I want to introduce some administrative data. So again, looked around, found some reasonable base file or import reuse file, which defines an aspect called managed, where I have a timestamp where I can store information about when this entity and when an entry was created or modified. So again, I add a using clause that pulls in the file, defines a name, and now I can make use of this aspect. I can include it in my books entity, and now my books entity has the additional fields. I also wanted to use it for author, but I don't want to mess up with the authors file for a reason I just explained. So I again use my extend feature, which can not only extend with single elements or annotations or associations, but I can also extend with an aspect. So now I tell the compiler to just kind of inject this managed aspect into the authors entity. And then I realized, well, I don't want to only have timestamps, but I only want to have some user information. I want to be able to store some user information when who created an entry or who modified an entry. So what I can do, I could, of course, again, go into the base file and add the elements here. But for the reasons that I don't want to mess with the imported model, I can do the same here. I can now extend this aspect, which is defined elsewhere, with these additional fields. And as they are included in the books, and as they are also included via this extended authors, now all the in my entities, books and authors have the additional fields. So let's try whether I did the right thing. So let's go and just again compile the season for this model and check what comes out. So we see the books entity has these additional elements from the aspect and all the elements, all the 4. And my authors entity has first of all, the new annotation here, not name anymore as it was in the beginning, but author name. It has the additional elements city and country. It has the annotation that I injected here, and it has the fields coming from the aspect. So everything is nicely there. But it goes on. Now I want to do it here. Define a service where I project the books entity and the authors entity. So I just expose these two entities in my service. And now I want to bring another aspect into the game. And this is in my authors entity, I have a field called country. And I saw there's another reuse model which defines a nice entity country. So I want to bring that into the game. And what I actually want to do is I want to add a projection to the country's entity into my service. And I want to add an association pointing from the author's projection to the new country's projection. But for some reasons, separation of concern, I don't want to do that here, but I want that everything that has to do with countries is done in a separate file. So again, reuse the extent. So I have another file where I access my service, where I access the countries with these two usings, and I define a projection, P countries, on top of the countries entity. I want to be a part of my service, and for this, I don't have to say extend service with, but the cool thing is, if I define an entity and the entity has as a name prefix, the name of a service, then this entity is part of that service. Yeah, I can just by this name convention decide whether an entity should be part of a service or not. I could, by the way, also go here and say, well, I define my service like this. It's just a service definition. And then I say I define the entity P books and P authors with this prefix. And the effect is just the same. Yeah, so that an entity is part of an entity, that an entity is part of a service, you don't have to include it in these curly braces. It's just by doing the name. So that's exactly the same stuff. All right, so go back here. I want to go here. So I have now introduced a projection on the country's entity in the service. And the final thing I want to do is I want to extend the author's projection. And I want to add to the author's projection a new association. And this is also possible with an extension. Now extend it, add a new association to country, which is just association to countries with this given on condition. So finally, I want to have a look at some special instance or special case for doing extensions with annotations. For that, I go into a new model. Let me see, it's here. So start a new, forget what I said right now, it's a new model. Here I have an entity books with two elements, title and price. And I want to make a little Fiori UI. So I added the line items annotation. And now I have two extension files, Y and Z. In Y, I add the element ISBN to my books. And I also add a line item annotation because I want ISBN to be visible. And in the other extension, I add a description field and also have the line item annotations added because I want to be a part of the UI. Now, I told you before, if I annotate something with an annotation that is already present in the base model, then usually we overwrite it. Of course, that's not what we want to do here. I don't want to overwrite my base line items annotation, which is an array, but I just want to introduce new elements into that array. And this is possible with this special syntax with the 3 dots here. This tells the compiler when applying this extension, don't overwrite the complete array, but just take here where the 3 dots are, take the old values that are already in the array and just add the new values at the end. So now let's just run this application with CDS watch. I can start up the compile or the whole node runtime and see that should work. And then I go just to my local host here. I have a Fiori preview and I see all the fields are there. Title, price, ISBN, description. Now you may wonder, can I somehow control the order of these two extensions? So if you would just compile this model, the compiler would tell you, oh, unstable order of array items due to repeated assignment of the same annotation. And that's what I do here. I have a base annotation line item. I have two extensions, both extend with line item. How should the compiler tell which one to apply first and which one to apply second? And this is also controlled by using. Now, using does not only determine the full set of files that should be compiled, but it also introduces a hierarchy. So if I now, what do we have first here? We first have this ESBN and then the description. If I just wanted to have the description first, what I can do is the following. I say, well, base is base. And then first I want to apply, sorry, I want to open this file here. I first want this set file to be applied with the description. And then I want Y applied. So I do that by saying, well, Y is not using directly base, but Y uses set. Yeah? So we have Y using set using base, and then we have the base. So then that should result in first apply the description extension and then apply the ESBN extension. So we need to wait until server has restarted, going back to the UI. And now we see description comes first. So notice if you, for some reason, need to control the order in which extensions are applied, make use of the using and just order the files in the right order to make that happen. All right, now let's switch to the next topic. By the way, in these slides, which will be made available to you later, I have put links to our documentation where you can find more information about the single steps or single stuff that I mentioned here in this talk. Now let's go to the calculated elements. So let's just again do a clean up here. Let's go here and let's go to the calculated elements. Database model. Again, I want to have it here and just close some of the other stuff. Okay. So in CDS, we have a feature called calculated elements, and we have three kinds of calculated elements, which are calculated elements on read, calculated elements on write, and association-like calculated elements. The funny names I'll just explain when I go through these features one by one. Before doing that, let's have a look at that model. Again, it's about books and authors. I think today everything is about books and authors. This time I have here my base entities with books having a title, a price, and a stock. So how many books do I have in my store? And the authors has some names, first name, middle name, last name. I have also defined a service where I do a projection on these two entities. And here I have added some computed fields because this is what I want to do. I want to add some computation here. I want to add some fields which are determined, computed based on some other fields. So I want to introduce a stock value, which is just a multiplication of price with stock. And depending on how much books I have in stock, I want to grant a discount of 30%, say. So this is something I add here in my view. And this is nothing spectacular. This is working for a long time. I just can add some computation, some computed fields in a view. Same I do here for authors, where I just concatenate the single names that I have. I also have another file where I just have some line item annotation so that I can quickly open a UI where you see all that. So again, starting CDS watch now in the calculate elements folder. Wait until the server is up and running, and then just go back to localhost. And here we have my books and authors projection. Looking at the books, we see the computed field stock and stock value with the correct numbers, I hope. And if you see the orders, there will also be the full name field, which is just a concatenation. Oh, I should increase size a bit. Yeah, we have the full name with the concatenation. So everything the way I want it. But not quite the way I want it because, well, first of all, I prefer clean and neat services, but now I have in my service projection this lengthy expressions. Second thing is maybe I have several services which all make use of books and authors, and I want to use these expressions, these fields also in these other projections. What can I do? Well, I don't want to then again define those fields over there. So one way of curing that would be to introduce another view layer, so an helper view on top of the basic model entities, books and authors, where I introduce these fields, and then just place my projections in the service here and here on this helper view. But actually, we have something better, and that is the calculated elements. And that is what I'm going to show you, what I'm going to show you now. So first of all, let's just remove this and go back to a service that is a plain projection of the basic entities, books as projection books, authors as projection authors, and that's all. Now in my books entity, I can do the following. I can define a field called stock value. So by now it's nothing new, it's just a regular field, but now it comes to new stuff. I can say I add an expression here, and this is price times stock. So I do the same expression as I did in the view definition here, also in the other file, but I can do it directly in the entity definition. This is a calculated element on read. I can do the same for the discount. I say, well, I do it like this. For syntactic reasons, I have to add parents here. And again, the same expression. If stock is bigger than 100, give me 30% of a discount. And the same here with the full name. I just want to say, and here I just copy paste this expression from here. String, full name is a string, and the expression I tie to it is just this concatenation expression. And I have to add the semicolon at the end. So now it should be fine. All right. So what do? I add an expression with this equal sign. This is a syntax for calculated elements on read. Concerning what expressions can I use here, basically you can here use the same expressions as you can also use in a query, with one exception. You cannot use subqueries here. Theoretically, it would be possible, but this is just something we have not implemented yet because no one asked for it. What I can also do in this expression, I can use paths. I can just say, okay, the expression here is just a path expression where you go to author and grab a field from there. You can also build calculated elements on top of each other. So here in my discount, I could also say, well, take the stock value. So now this calculated element here depends on this one. Oops, don't want to do that. And this is also what I do here, yeah, because from the author entity, I don't take a regular element. No, I point to this calculated element. So that means you can base a calculated element even on another calculated element in another entity. All right, so this is how you define it. How does it behave? From a user perspective, such a calculated element on read is a read-only field. So you must not provide a value for this calculated elements in a write operation. And when you read or when you select these elements in a view or in a query, well, then it just returns the result of the computation. This is what we do here in our projection because, well, actually saying nothing as a select list is the same as writing a star. And a star would include, for example, the stock value. So what we do here is just we select these calculated elements from the base entity. And now, as I have now changed the whole model to using these calculated elements, and since my server is still running, if I now go to the UI and wait until it refreshes, I should see exactly the same as before. Yeah, the same values, but now they do not come from the expressions computed value in the projection, but now they come from these calculated elements in the base entity. Next question, of course, is, well, how does that work? So this calculated elements on right are a pure CDS mechanism. So what actually happens is each time you reference such a calculated element in a runtime query or in a view, the compiler or the runtime replaces this access to the calculated element by the actual expression. So we can see that when we have a look at the database model that is generated here. No, I should go here. So let's just compile this to SQL and have a look at the SQL statements. So entity becomes a table, but you don't see any trace of stock value or discount in that table. Yeah, this is a pure CDS metadata, same as full name in the author's entity. But now if we look at the view, so here you see we have this reference to the calculated element, but here in the view definition, you see that this calculated element has been replaced by the actual expression. Same for the other calculated elements, yeah, for this discount, and here for the concatenation. And here this path even led to a join, and then from the joined entity, we again get this concatenation. So from how this calculated element on read works, this also explains the name on read. It's a calculated element on read because the expression is evaluated when you read from the entity. Based on how it works, it should also become quite clear that from a SQL perspective, there is no difference between using or defining and referencing a calculated element or writing the expression directly into the SQL view or in the query, because the final query, the final result is the same in both cases. So in the runtime, there's no difference between using calculated element or not. But the beauty of it is that it allows you, that this calculate element allows you to write nice and clean and concise models. First of all, here, the expression stock value and discount is right next to the values it uses. Before it was like here in this entity, in this file, I have price and stock, and in some completely other file, I have this expressions that makes use of it. Here, everything is next to each other, and thus it's easier to understand what's going on. And the thing second and more important is the reuse value. Yeah, you define this expression here, and you can use it in views, you can use it in runtime queries as long and as often as you want, but just have to define it once. So calculated elements on read are a great tool of defining nice and clean models. Now let's come to the next variant of calculated elements, and this is calculated element on write. How do you define it? Precisely the same way, but then you just add the keyword stored at the end. Now this is a calculated element on write. How does it feel? How does it work? Well, from a user perspective, it's the same. It's again a read-only field. You must not provide stock value or discount in a write operation. And when you read from it, you get the result of the computation. Proof is just restart, make sure the server is restarted. Now we have the definition of the calculated elements on write. If we go back to the UI and refresh it, you should see exactly the same thing. Yeah, nothing has changed. I should even increase it a bit or make it like this, because we also now have the author name in our model. Yeah, but the results are the same. So in the result set, you don't see a difference between calculated elements on read and on write. But how it is handled internally, that is completely different. Because now let's have again a look at the SQL. While a calculated element on read is handled completely on CDS level, the calculated element on write is handled completely in the database level. So kind of a push down has happened. You now see, if you look at the books table, there now is a column stock value and there's a column for discount. And we have here used this generated always as feature of a database. This generated always as feature works like the following. Each time a value or an entry is inserted in the table, or a value is, an entry is changed, the expression is evaluated and the result of the computation is stored like a regular table field. which now again explains the name on write, because now the expression is evaluated when something is written into this table or this entity. That means we have kind of moved the time of evaluation from read to write, which has, of course, impact on performance, because now we have an improved read performance. Why? Well, simple. When you read from that table or from that entity, you just read a value that is stored in the table like all the other values. So in a way, this is a kind of a cache mechanism. So this allows you for efficient read. And this means you can also now efficiently filter or sort based on these fields here. And it even allows you to use HANA functions like the HANA contains that doesn't work on expressions, but it works on fields like those. So you could say now, well, great. I always use calculated fields on write for everything that is computed. You shouldn't do that because you need to know you pay a price. For the cheaper reads, the price you pay is more expensive write. Well, that's maybe not that important, but what is important, the fields are stored. So that costs memory. So be aware you store redundant information because the value of these things can be computed all the time. So again, it's kind of a caching. What also is a little drawback is the expressions that you can use here in this calculate elements are a little bit more restricted because you cannot use subqueries here. You also cannot use associations because you may only use other fields that are kind of in the same table row. And also, if you use functions here, they are also a little bit restricted. You can only use so-called deterministic functions. Another point is your database schema gets a little heavier. By heavier, I mean migrations are maybe difficult if you have these calculated elements on write or these generated columns. And changing the expression once there already are values in your table may even not be possible. I think it works on HANA, but on other databases, that may be problematic. So the essence of it is you can use it, or we should use it, but only if you, or put it the other way, make heavy use of calculated elements on read, but use calculated elements on write only if you really need the performance boost. Which brings us to the last form of calculated elements, which are the association-like calculated elements. The on read and on write that we have seen so far have something in common because both of them evaluate to a value. Now, it's not surprising that a association-like calculated element evaluates to an association. So what we do here, we define a field called available books, and we say this is the same as books. Books is an association with a filter. So what you do is you define a new association, available books, which kind of inherits from the original annotation books, the target and the on condition, and just adds a filter to this on condition. So we can see how it works by looking or by doing, where is it? Here. We now do a direct get query in OData. First of all, we send an expand on the original association books to the authors entity, and we see here that Jane Austen has 2 books, but one of them, Pride and Prejudice, nothing is left in stock. That means if we now do the same get, but now expand with this derived association, with this additional filter where stock should be greater than 0, then we should see only 1 book for Jane Austen, namely this one where we have 2 in stock. So this allows you to derive kind of more strict associations. You would usually use that together with compositions. Here we have a model, books and books text. So this is what would come out of the compiler when you use the localized feature. Yeah, if you would model localized by hand, you would find something like this here. We have here in books a composition of many books, texts. So this is a composition that points to all translations of a title. And then we have a kind of specialized association, which is here modeled by hand, where we say association to books text on, well, make more or less the same on condition, but additional this filter locale. So now with this new feature, we could just change the definition and say, well, localized is texts, but with an additional filter, locale equals $user locale. And now what happens is, first of all, if you use a composition with a filter, it's turned into an association. So that means you now have the same association as defined here, but just defined in a way more nicer way. And the model also kind of notices that this association stems from that composition. So in the runtimes, there may be situations where you get a little performance or optimization based on this knowledge. All right. One final thing is I can now also kind of combine calculated elements and extensions. So assume you have a huge table, a lot of fields, a lot of entries, and you want to add a new field to that entity. But actually, you don't want to touch that table. Yeah, you don't want to migrate it because it's so huge and you're frightened and, I don't want to do that. So how can you do that? Anyway, you can define an extension entity. Yeah, define a new extension, define a new entity. When as key, you just use the same thing as the same type as in your original entity. Yeah, so the keys match this and this one, and you define an association, say to X, and no, sorry, and here you add just your extension field. Yeah, you have an extension entity, and the extension, the new field is added here. Then you extend your original entity and just say I add an association, which is an association to my extension entity, and this is not right, where I just say, well, the ID of the original entity should match the ID of the extension entity. And then I add a calculated element, x, which is just 2x dot x. Yeah? Both of them are pure CDS metadata, so they won't change the table for this entity. But as I now have injected this calculated element into huge one, it feels like, at least on CDS level, the field would be present in here. So I can, in a projection on it, just use it, yeah, as if it would be part of this one, but actually it's stored in another table. All right. That concludes the part on the extension, and I come to my last topic, which is expression in annotation values. Again, before I continue, do a little cleanup. Okay. Now, first of all, expressions as annotation values is a pretty new topic. It's still a beta feature because some aspects are still missing. So you can use that part of it that already works, but I will explain in the end what is still missing, so where we need to do something, and we are already working on that. So far, if you wanted to have an expression as an annotation value, you had no choice but writing it as a string literal. Yeah, as an example here, this is restrict annotation. And when you define a user instance, an instance-based authorization check, you would have to provide this where with an expression, which is just a condition that is applied. Now, having to write this as a string has a few drawbacks. First of all, each consumer of this annotation needs to be able to parse that and understand what expression that is. Second is you don't have any compiler checks whether this is correct, neither syntactically nor whether the expressions or the paths you use are correct. And of course, you also don't have any editor support in writing this. So this becomes possible now when you use the new feature, annotations, that can have expressions as annotation values. So just define any annotation. And now I want to make use of this new feature. I want to write an expression as annotation value. First of all, syntax. If you want to do that, you always have to use parents. Yeah, there is no exception to that rule. If you want to use the new expressions, use parents. And now you can write an expression directly as syntax here. You can do literals, but of course now you can also access elements of your entity like name, or maybe also drill down into a structure like here, sizes dot, and you see you get code completion. And if you make a mistake, I thought so, compiler should notice, or editor should notice. Well, we could try to compile it. Let's have it here. Let's say compile. Where are we? Calculate elements. No, it's because we're here. Let's compile this file with the number 2. Yeah, compiler tells you sizes. Well, you misspelled it. I don't know why it does not work in the editor right now, because I had expected that the editor already tells me it's wrong here, but at least once you compile it, you get this information. Okay. Here again, the question, what kind of expressions can you use? Same answer as for the calculate elements, more or less. You can use everything that you can do in a query, except of subqueries. This is also something we have not implemented yet. All right. Now let's go back to our original one and now try to use this for the projection service, or for this instance-based authorization, which is expressed via this annotation. So just replace the string literal with our new syntax, and now the editor tells us, something is wrong. First of all, member, well, it should be members. And editor, well, you don't need this escaping anymore, and there's still something wrong. There was an additional parent. Yeah, before we didn't see it because the compiler did not check. Now it tells it to us. And that is great, because before, if you made a mistake in this string literal expression, you would only notice at runtime. You wouldn't get a runtime error, or maybe it would just not work. But now you get also already information when you compile it. All right, but this is not everything that we do. So we support you now in writing and getting right calculations, expressions in annotation values. But there's more we do, and that is the compiler ensures that when annotations are propagated, the expressions stay valid. So look at that example. I have an order. An order has a price, and usually you have a currency that is linked to the price. Here we use the annotation that tells, well, the currency for price is currency. We have a projection where we just project price and currency. Everything nice, everything good. Let's see if we now compile that and look at the season. You will see here we have the projection order, and we have the elements with this annotation. Now you see I don't use the parents here. Well, this is the way that this is something that the compiler allows from day one. You can write a path, syntactically write a path as an annotation value. But the point is, actually, this is not treated as a reference or an expression or a path. Internally, we just treat it as a plain string. So you won't have any support for this string. And you can immediately see that, for example, if we forget to publish currency and recompile it, compiler doesn't care. Yeah, he knows, well, here is a currency annotation, but I treat it as a string. I don't know what it means. I don't know that it's a problem that I don't have an element currency. Or if for some reason you would have to rename or want to rename the element, if you compile, compiler doesn't care. The annotation still says currency. And now comes the beauty of the new expressions. If you use this new syntax and tell the compiler, well, this is an expression and this is a reference, and compile it again, well, say first we forget to project the currency. Compiler now tells you something is wrong. The value that you have inherited, so the propagated annotation is wrong because you don't have the currency. Okay. And if you project the currency, but rename it, what happens? Well, the compiler now knows, oh, I have a reference to currency. If I project the annotation to price here, currency has been renamed. So I would have to rewrite my annotation, and that is what's happening here. Yeah, now you see this reference has been changed to cookie. By the way, he can also see how such expressions in annotation values are stored in the season. You see, you have here this reference. Yeah, and if you would have a real expression like we have in the file before, you would just see the parsed version of this expression in the season. So a user would not have to parse the string value. He can really access the parsed version in the season. All right, so compiler makes sure that when propagating, it stays correct. But not only that, we received now and then a request from someone who said, well, I have a lot of prices in my model, and all of them come with a currency. Cannot I just define a reuse type, a structure type with, a structure type with two elements, value and currency, and with the correct annotation? Yeah, define it once and just use it everywhere where I have a price. And of course, then if I do the projection, I only have to project price. Well, it's a nice idea, but it didn't work because same problem. What happens if you build the OData? We can have a look at it. So compile that to OData, have a look at the EDMX. So what happens? Well, in the EDMX, this structured element price is flattened out. So it results in price value, price currency. Here the currency, again, it's not the new annotation expressions. It's the old string-like thing. Compiler doesn't know it has something to do. So we have an annotation that points to a field currency, which is not there anymore. Also, this is cured by using the new expressions. Now the compiler knows, okay, currency is a reference. Well, if I flatten this out here, then probably I have also adapt the reference in the annotation, which happens. It does happen, yeah? Now the annotation has been rewritten, and now the path points to price underscore currency. So the flattening is also represented in this reference. And it becomes even better. Let's see, I have 7 minutes, so that should work out. Let's go here. I have again prepared a little Fiori application. So I have a very simple model. No, not here, but here. An entity with two fields, status and value. Status is an enum, O open, A accepted, X integer, and a value. I have put a projection on it where I just project these values, and I made a Fiori UI. And I want the Fiori UI to be colored. Actually, what I want to do, I want to print the status in colors depending on the value. I want to print the value in colors depending on its value. So if it's less than 80, it should be green, and so on and so on. This can be done with this annotation criticality. Thing is, the criticality annotation expects as value an integer that encodes the color. So I have to somehow map the values of my status to this integer. Same for value. I somehow have to map the value of my integer to this integer that represent the colors. Furthermore, I have an action, do something, and I want that this action is only available if the status is not X. So this also can be done with an annotation, core operation available, but this core operation available expects a Boolean that tells it available or not available. So I have to map somehow my status to this Boolean. Now the great thing is, Fiori for some annotations allows dynamic expressions. That means you can put an expression into your annotation, and then this is evaluated in the backend. And that actually is what should happen for a UI annotation. If we need some mapping, we want that to have happen. We want that to happen in the backend, not in the backend, in the front end, in the UI, in the client. The bad thing is, or well, not bad, but not so nice, if you look at the syntax that you have to use to do that. So this is the original OData syntax that you had to use so far. If you look at that, you realize it is pretty hard to get that right. And this is what we tried to improve, because now that you can write an expression into an annotation value and the compiler understands that expression, what can do the following. We can allow you to write the expression in CDS syntax. So let's try it. I want the following. If status equals O, I want to have a 2. Otherwise, if status is an A, well, I get it already here. I want to have a 3. Otherwise, I want to have a 0. Oh, I forgot something. So let's draw this back. So this is the old, using the old annotations of Fiori. I wanted to prove to you that it's working. So I again start my application and have a look at the UI here, Fiori preview. And I see, yeah, all the values are nicely colored. Yeah, O is a yellow, green, A is a green, and X is gray, and same here. And if I select a status A, the action is available. If I select an entry with status X, the action is not available. So exactly what I wanted. Now I start replacing this weird annotation syntax with our nice CDS syntax. So do the same here. So now criticality, I think what I get proposed here is pretty right. Less than 83, less than 92, otherwise a 1. And I want to do the same thing here for the core operation available. So now, well, look here. What does it mean? So this is the syntax of CDS. No, not of CDS, of OData. In is a implicit binding parameter. Yeah, do something is a bound action. Bound action has an implicit binding parameter in which points to the entity. So all this says in OData language is go to the entity and grab the status. So how do we express that now in CDS? So if you are in an action and want to refer to an element in the entity, you just say $self. Yeah, $self represents the entity we are living in. So this bound action lives in this entity. So $self is this entity. And now I just can say status. So now I have access to my status element and say, well, should not be equal to X. Now we save that. The server restarts. And we have a look at the UI, and we should see it's precisely the same as before. We have the nice colors, and if we look at the action, here it's working, here it's not working. So this, I think, is really a great feature. We can provide support for writing annotations with expressions. You get compiler support. The compiler makes sure it's correct when you propagate it through the stack. And we can do even this nice transformation of nice CDS syntax to a little bit weird OData syntax. And with that, I think right in time, that is all I wanted to show to you. Thank you for your participation.
Thank you, Stefan, so much for this really great session. Just wanted to let you know, all the attendees and viewers, this video will be available as a recording in the Devtoberfest playlist, as well as in the CAP playlist. So you can rewatch the session at any time. If you have any questions, leave the questions down below in the comment section, or go over to the community.sap.com. Ask your questions right there down below in the comment section of this community session event. And with that, I would say thanks again, Stefan. Until next time, hopefully. And see you in the next session, dear viewers. Bye.
Bye-bye.